Hello, and welcome to Intermediate Algebra, Unit 4, Lesson 5, Systems of Linear Inequalities in Two Variables. Our lesson objective is to graph the solution set to a system of inequalities in two variables. We just finished working with, in the last few lessons, we worked with equations with two variables in a system where both equations had to be true. This is very similar, except instead of an equal sign, we'll have an inequality sign. So, in Unit 3, Lesson 4, we did the same thing. We transferred from equations to inequalities. You graphed the line and you shaded the side that represented the solution set. Really, the only difference here is you're going to do that twice, and where the solution sets overlap is the answer to your system. Those points will make both inequalities true at the same time. So the process is you graph each line, then you shade the side that makes the inequality true for that line. You do it again for the other line, shading again in the overlap area is your solution set to your system where both inequalities will be true. So, to find the solution set, here's an example. So what you notice is we do not have equal signs, we have a greater than sign, and then we have a greater than or equal sign. You have to remember that when you're graphing inequalities with lines, if you have no equal sign, if it's just a greater than sign, you use a dashed line. If you have the equal sign, use a solid line. You're going to apply that to this also. So graph the first line by any method you choose, and use a dashed line. Then graph, and then choose the side of the line to shade. You want all values greater, so you're going to shade above that line for this first one. If the equation weren't in slope-intercept form, I could choose some points and just, instead of shading above, I would choose a point that's not on the line and see if it makes the inequality true. If it does, I shade that side. If it doesn't make it true, I would shade the other. You might want to review the last lesson in Unit 3 if you're having trouble understanding this. So, here is my first inequality graphed with a dashed line, and I've shaded all the y values that are higher than the line. You see, if this is my line, this one is higher than the line. So that's how I decided which side to shade. Now I'm going to graph the next line. I'm going to graph the line that is the boundary of the next inequality, I should say. So this blue line on this slide, on this graph, is y equals x minus 2. And I make it solid because that second inequality includes an equal sign. Now I have to choose which side to shade. So I want y to be greater than or equal to x minus 2, so I'm going to shade above the line. Since it's in slope-intercept form, I can do that without thinking about it. Or I could say, well, does 0, 0 make this true? Is 0 greater than or equal to 0 minus 2? Yes, it is, so this is the side I'm going to shade. We'll see that on the next slide. And you can see in this blue area here, this is the whole solution to that second one, but what's of interest for a system is this area where both are shaded. This is my solution, so you would note this as the solution area. You would have to let somebody know you knew that was the solution, not just draw a picture. Okay, and again, that's what I did. I would say, I would write solution and put an arrow to it, to that section, or something to let me know you're not just making a picture. That you, if I ask you if some point is in the solution set, you could plot the point and see if it was in that double shaded area. And if it is a solution. So let's go on to example 2. This one, again, both are in slope-intercept form. And when I graph y less than or equal to 3x minus 5 and y greater than x minus 2. So I'm going to try to do the best I can here with a hand-drawn graph. The first one I'll do in blue. So 3x minus 5 I will, oops, sorry, I never remember when I have this marking thing on, I can't change the size of my screen without marking. Let's try this again. So 3x minus 5, my y-intercept will be at negative 5. I can go up 3 and over 1 to get the next point. Let me check. That's 1, negative 2, 3 times. Yep, that would be on the line. And then I can go up 3 more over 1 and get another point. And I'm going to freehand this best I can. Yeah, let me try that again. Better. Straight edge on paper will work much better. Now it's a solid line because there's an equals. And the second line I'll do in red. And that's y greater, oh, I haven't shaded yet. Wait a minute, I'm not done. So this is y is less than or equal to 3x minus 5. So I'm going to shade this side over here. Those are underneath. And if I want to check a test point, if I put in 0, is 0 less than or equal to 0 minus 5? No, it's not. So I would not shade the side that had 0, 0. So I have shaded the correct side. Whoop. And in red, I'll do the other inequality, x minus 2. Now this one I have to make a dashed line. And it has a slope of 1, so I go up 1 over 1. But I have to do a dashed line. And then I want greater than, so everything above the red line, greater than. So if I had more carefully shaded my blue, I would see that my solution area is here where both are shaded between the two lines here. That is my solution area. So here's a second example. This one is not in slope-intercept form, so I can plot some points or any other way I want. I can turn it into slope-intercept form, but you have to be careful to change the sign of change the direction of the inequality if you divide by a -1. I am just going to, for the first one will be in blue, make a table of points. I'm going to use intercepts. So if x is 0, and so I pretend it's an equal sign here when I'm plotting points, because I want to plot the boundary. So if x is 0, and I want negative y to be equal to 4, then y has to be negative 4. And if y is 0, x will have to be 4. So I get 0, negative 4 is one of my points, and 4, 0 is another point. And I connect those. Now I'm going to connect them with a dashed line because in reality I have a greater than sign, not an equal sign. And there's no equals involved in it. Okay, that should be dashed. I didn't do a very good job dashing the end of it there. Then I will look at the second equation, x greater than negative 2. Well, wait a minute, where's my y? Well, let's pretend we're graphing x equals negative 2. That means I cross the x-axis at negative 2. Oh, it's going to be a dashed line for my boundary because it's not equals, it's just greater than. And the values of x greater than negative 2 are everything to the right. So let me go back. I did not shade the blue one. So the blue one, x minus y greater than 4. It's not in slope-intercept form. It's not clear whether we're on above or below. So I pick the point 0, 0, and I do 0 minus 0 greater than 4? No. So I don't shade that side. I shade the other side of this line. So now for x greater than negative 2, everything to the right is greater than negative 2. So my solution set is the overlap, which will be everything from here on over. Okay, so that's the solution to example 2. Let's move on to example 3. Neither of these have two variables, but that's okay. Just I'm doing a little review of graphing horizontal and vertical lines here also. So x greater than 2 is my first equation. So that means I cross the x-axis at 2, and there's no equal sign, so it's a dashed line at x equals 2. And the second equation is y greater than -3. I cross the y-axis at -3, and I draw a dashed line. Oh, once again, I'm in the bad habit here. So for x greater than 2, let's go back to this one. The x is bigger than 2 or to the right. You can almost think of this as a number line when it's just one variable. So I get all that. And for the y's, greater than -3, greater will be above the -3. And you can see my overlap is right here. That represents my solution set. So let's go on to example 4. I get y, these are both in slope-intercept form, so they're not too bad to graph. Standard methods will apply. First one is y less than or equal to -3x plus 1. So there's my plus 1. The slope is negative, so I go down 3 and over 1 to get my next point. Down 3 and over 1 to get my next point. And I'm going to use a solid line because it's an equal sign. And I want to be less than that solid line, so I will shade everything over here. And I'm going to graph my second inequality using red, greater than -3x plus 3. So there's my y-intercept, and again it's 1, 2, 3 over 1. I didn't do that right, did I? Yeah, I did. 1, 2, 3 over 1. So I get a line like this, and I want to be greater than that. And what I see is there's no overlap. So this one actually has no solution. These are, again, parallel lines, so they won't intersect. Now, if this had been a less than, everything to the you would have had an overlap, or if the first equation had been a greater than, you would have had an overlap. But in this case, there is no area that gets shaded by both, so there's no solution. So there are several problems for you to try. There are 3 problems. You want to stop the video at each problem because the next slide will have the solution. So stop the video after the first problem, do the problem on your guided notes printout, and then check the solution by restarting the video. See the second problem, stop it again, and check the solution. So here's your first problem. You try it number 1, y greater than -x plus 4 and y greater than x minus 3. Graph that and indicate the solution set. Stop the video. Now you're back, and here is the solution set. Notice both lines are dashed, so it's kind of that top section that's the solution set, the double shaded section. The next problem for you to try is here, and these are not in slope-intercept form. Stop the video, graph these, and try to find the solution set. Okay, you're back. Here is the solution set. It's what you see in purple on the screen, essentially, the double shaded area. Notice one of the lines is dashed because there's no equals included. That would be the second line, and the other line is solid. And now the final problem for you to try is here. Graph these inequalities and find the overlap to find the solution set of the system. Stop the video now. And here is the solution set to that one. Thank you for joining me in this edition of Math Teacher to Go, and we'll see you next time.